Hello everyone, welcome to Ilustraca. In this lecture, we're going to discuss about a very important topic, which is partial safety factor for temperature load in load combinations. So many has confusion about this particular topic, which is this partial safety factor for temperature load, because in our code there is no clear mention about this particular thing, right? So if you see IS 456-2000, there is also what should be the partial safety factor that we need to consider when we are combining the temperature load with our other load combinations. It is not mentioned correctly. Even if you go for IS 875 part 5, there also the load factors are given as 1. Okay, you can refer that code book. Load factor is given as 1, but what should we take when we are designing it for you can say ultimate cases, the strength design when we are performing, then what should be the partial safety factor? It is not clearly mentioned. So we'll try to understand from different publications, and we'll try to conclude something. And obviously it is all about engineering judgment, which we'll get to know in a while. So let's get started. So first of all, I will jump into SP 24 1983. Okay, so this is nothing but the handbook for our old IS 456 1978, correct? So this is the special publication 24 1983, and here in this page number 114 we have the mention for some load factor that need to be considered when you have temperature load. So you can say where structural effects T of differential settlement, creep, shrinkage, or temperature. So any of this can be there as T. So temperature change may significant in design. Okay, so when you have this conditions which are significant, which can actually make some significant difference in your design. So in this case, the required strength we need to be assessing using this combination U is equal to 0.75 multiplied by this whole combination 1.4 times dead load plus 1.4 times T. Now I'll be considering this T as a temperature load, so 1.4 times temperature load and 1.7 times live load. Okay, again it says that when you are taking, so whatever force you will be getting from this combination, so again it is saying U shall not be less than 1.4 times dead load plus temperature load. Okay, so that means the ultimately we have to design for this both, and whichever is the greater one, whichever is giving the critical condition, need to be considered for your design, correct? So the first one I will just write it here, that from SP, because we can compare them, right? So from SP 24 1983 what we are getting, that the combination is 0.75, okay, 1.4 times dead load plus 1.4 times temperature load. I will write it like this: temperature plus 1.7 times live load. Okay, so ultimately what we are getting from here, 0.75 into 1.4, I think 1.05, something like that. 0.75 into 1.4, it is around 1.05. So we are getting final 1.05 dead load plus then again 1.05 temperature load plus, now it will be 1.7 times live load. So I will change this to 1.7, and we are getting 1.275 live load, right? This is what written here. Yeah, okay. So this is one combination. The other combination is 1.4 times dead load plus 1.4 times my temperature load. Okay, so these two we are getting from SP 24 1983. Remember, this is not mentioned anywhere in IS 456-2000. Okay, so this is one set of combination, but now these combinations are not having the lateral loads including with these, right? So these are only the gravity combinations. What about the other load? So if you see IS 875 part 5 also, so IS 875 part 5 also giving combinations with no safety factor. That means with unity considering 1 as the safety factor. For the ultimate design, that says that you have to consider the design combinations, I mean partial safety factors, according to our design codes and according to your engineering judgment. So it is also not clear. Now if I jump into my another code, let me just show you IS 875 what it gives. So IS 875 part 5, if you see, it gives combination like this, like what sort of combination can be there. So dead load, live load, IL means imposed load, dead load, wind load, seismic load, temperature load, TL. Okay, again you can see these things are there, but what factor of safety you should take, I mean partial safety factor you should take. If you see here, the relevant design code shall be followed for permissible stresses when structure is designed by working stress method, and for partial safety factors when structure is designed by limit state design method for each of the above load combinations. So you need to go for any relevant design code, but our design code also didn't have mention of this temperature loading, correct? I mean partial safety factor for temperature loading. So it is not clear from this particular code also. Now if I go to IS 800 3.5 load combination, here also some load combinations are mentioned, and if I just go down here, so 3.5.7, if you just read this, it is saying stress developed due to secondary effects such as handling, reaction, temperature, and settlement of foundation. So the same that we have got in SP24, right? If any, shall be appropriately added to the stresses calculated from the combinations of loads stated in 3.5.1 that we have seen above, right? 3.5.1, this one, right? These combinations, okay, with appropriate partial safety factor. Again, what is the appropriate partial safety factor? No mention here. So there is table 4. Table 4, if I just take you to table 4, I think here, and here also you will see there is no such mention about any temperature loading, okay, or partial safety factor for temperature loading. So these codes are not helping us. Now what I will do, I will go to another very you can say popular code, which is UBC 97. Obviously it is not in use anymore. Now we have IBC, but let us see what UBC wants to, someone tried to say that about the temperature loading. So the basic combinations, obviously all the load you can say codes are, you can say, prescribing some basic load combinations with the common load cases. So first of all, I will just directly jump into this point, 1612.2.2. okay, so it is chapter 16. okay, so you have to come to this section 1612, and here you will find this particular mention here. So sorry, let me just zoom this a bit. So it says that other loads, okay, 1612.2.2, other loads where F, H, P or T are considered in design. So F, H, P or T, what are those? You can directly read from the where we have this mention of the loads, right? So this is nothing but, let me see if I can show you anywhere. So these are basically, this T is nothing but the temperature load or self-straining load. Okay, I think it is mentioned somewhere. Let me see, this is page number 23, correct? If I see loads, it should be here. The terms of the load actually I am looking for. Let me just, I think it is in the different section. Anyway, yeah, I think it is here. Yeah, if you see here. So yeah, H is F is load due to fluids. H is load due to lateral pressure of soil and water. Okay. I think then we had P ponding load, S is snow load, T is self-straining force and effects arising from contraction expansion resulting from temperature change, shrinkage, moisture change, creep in component materials, movement due to differential settlement or combinations thereof. Okay, so you can understand that this T is actually also you can say corresponding to the temperature load. So if I again jump into this part, in the combination. So now we are clear about this F, H, P and T. So our main concern is T as of now. So what it says, where suppose T are to be considered in design, okay, temperature load is to be considered in design, each applicable load shall be added to the above combinations with these combinations, okay, combinations factored as follows. So 1.3 times flood load, 1.6 times H, 1.2 times bonding load, and 1.2 times temperature load. In case of design, it says, so let me write it here. For design, I'm not writing the other things here. For design, 1.2 times temperature load, it is by UBC 97. Okay, as per UBC 97, 1.2 times temperature load need to be taken in the design combination. And if I go just below here, if you see, this is my serviceability combinations. So now what it says, the other loads 1612.3.3, where F, H, P or T are to be considered in the design, that means my serviceability design, each applicable load shall be added to the combinations specified in section 1612.3.1, that means this one, okay, and 1612.3.2. so here we have some serviceability combination, here we have another one. So okay, so now the thing is, it is not mentioning what should be that, you can say, partial safety factor. Okay, what should be the partial safety factor that we need to consider? Can we see anywhere? I think so. In this case, what should be done? So we can consider that most of the load cases here are having partial safety factor as 1, until we are coming to this particular combination, which is for stability. So we can say that here for serviceability design, code has not mentioned directly, but it is actually meaning that when you are going for serviceability, in this case, unity should be the partial safety factor. Okay, so this is for UBC 97. I think I just missed the serviceability part in SP24. Let me go back to SP24. In SP24, if you see, there is a line for serviceability limit states, the partial safety factor can be taken as unity, that means 1, while considering creep, shrinkage and temperature effects. So that means when this is for design, right? These are for I should write it strength design. Okay, so for serviceability, let me take this part little below here. So for serviceability, it is saying you take like this. Or 1.0 DL plus 1.0 temperature. As per my understanding, this is what code meant to say. If code is meaning that you keep the 0.75, I don't think so. It is meaning directly this. So you can say, let me know if you understand, if you interpret this in a different way. Serviceability. Okay, so this is also coming from SP24, okay, 1983. So this is the set of combination from SP24. This is the partial safety factor for design and serviceability we are getting from UBC 97. Now let us jump into the latest code. Even IBC also you can say mention that for these combinations we need to refer AAC 7 2022, right? 22. So if you see here, so in AAC 7 load symbols, if you see, T is nothing but the cumulative effect of self-straining forces and effects arising from contraction or expansion resulting from environmental or operational temperature changes, shrinkage, moisture changes, creep in component materials, movement caused by differential settlement or combinations thereof. So T is nothing but our temperature load that we are looking for. Here are different combinations mentioned. Now if you just go down here if you see in 2.3.4 in ASC 7-2022, it is mentioned that the load combinations including self-straining forces and effects where structural effects of T, that means temperature load or other conditions that is mentioned here, are expected to adversely affect structural safety or performance. T shall be considered in combination with other loads. The load factor on T shall be established considering the uncertainty associated with the likely magnitude of structural forces and effects, the probability that the maximum effect of T will occur simultaneously with other applied loadings, and the potential adverse consequences if the effect of T is greater than assumed. The load factor on T shall not have a value less than 1.0. So when you are combining the self-straining effects, or you can say temperature load, with the other design combinations, they says that you need to decide how adversely you want to consider this effect in the structure, or depending on the forces developed by this self-straining load. So you have to see how much it is affecting the structure. So based on that, you need to decide a safety factor, partial safety factor, but that partial safety factor shall not be less than 1.0. So initially we can start with a thing that for design, I mean strength design, both are design only, serviceability also a design criteria. I should write it here. For strength design, the AAC 7-2022 says that you should take at least 1.0 temperature load, right? And if I go down here and if I read about you can say here I have the serviceability combinations, load combination for allowable stress design. So here if I go to, let me see where it is. Yeah, so if you see here 2.4.4 load combinations including self-straining forces and effects, where the same thing they have written all these things, like T is unlikely to occur simultaneously. Okay, in this case the fraction of T considered, this is the last line that is, because the upper part is same as that we have read before. So the fraction of T considered in combination with other loads shall not be less than 0.75. So in case of serviceability design, the ISA 7-2022 is recommending a minimum value of 0.75, right? So sorry, the partial safety factor for serviceability it should be at least 0.75 times temperature load. So this is from AC 7-2022, correct? So now there are other codes also. You can refer Euro code, you can refer BS code, you can read what they have written regarding this temperature or self-straining loads. So from here, when we are designing in the Indian context, so we can conclude like this, that these two combinations we can take, okay, though it is not mentioned in IS 456-2000 currently. So these two combinations we can take for strength design and this for serviceability design. Now here also, this, when I'm talking about the first combination, I'm not very much sure about whether it is 1.0 dead load I should go with, or it should be multiplied with 0.75 times again, because the background I am not sure about. So please do check this, but in the design it is pretty sure that we can go with these two combinations when you are combining the temperature load with the gravity loads, right? Now what my conclusion is, or what my suggestion is, when we'll be considering this temperature load with all other combinations that as of now in the you can say everyday design, the design combinations that we use. So when we'll be adding the temperature load with those combinations, so as per my understanding, what we can do, that when the temperature effect of the temperature load is not that great, okay, the extent of that temperature difference is not high, and obviously the developed forces are also not high, so we can go with this condition. Okay, 1.0 we can take for partial safety factor, we can take for strength design, and 0.75 we can take for serviceability. And when the effect of temperature difference is very high, forces developed are very high, we may go with the recommendations given in UBC 97, though it is not in use anymore, but there were some recommendation given. So because here also AAC 7 also telling us that we need to decide based on the extent of loading or extent of the effect that is coming due to this particular load on the structure, right? So we may go proceed with this recommendation, that 1.2 times temperature load for you can say design, strength design, and for serviceability 1.0 times the temperature load. Okay, so our conclusion is that for all other combinations that we'll be getting in our Indian context, I'm saying, so in this case, initially we should, we can go with this particular partial safety factor. Okay, and when the temperature loading is major, right, temperature difference is very high and it is causing high amount of self-straining forces on the structure, so in this case we may proceed with these safety factors, partial safety factors. Okay, so this is my understanding. Obviously it may differ with your understanding, it may differ with someone else's understanding. So please, if you're watching this and if you have a different opinion, please let me know in the comment box, so that we can say, obviously these things, as we do not have a clear you can say prescription in the code, so it is based on our you can say engineering judgment we need to consider. So do let me know your opinion also, what you are considering in your design. Thank you, and I hope this session will help those who are in the dilemma, because we all are in dilemma, what should we take. So maybe we can get some conclusion from this, and we can start at least some base values for the partial safety factor, start taking these base values from the partial safety factor for temperature loading. So this is it for today's lesson. If you have any opinion, your doubt, please write me in the comment, so that I can try to, you can say, address those. Thank you, and see you in the next lecture.